In June 2013, Alberta, Canada experienced extreme flooding due to heavy rainfall. This project aims to estimate flood levels in Edmonton based on flood inundation data from Calgary's 2013 flood event. Flood forecasts are a critical data point for decision-making in urban planning and emergency management, but data on recent flood extents isn't always available. In this project, we used a logistic regression model to forecast where flooding could occur in Edmonton based on past flooding in Calgary. This type of model is useful because it uses past inundation data from one location to forecast inundation for another similar geography. This model would be useful for Edmonton if the city's physical conditions have changed since past flood events. Decreases in permeable area, slope changes due to regrading, and changes in road coverage are a few factors that could change the potential extent of inundation beyond what has been experienced in the past. To begin the modeling process, geographic data was collected for both Calgary and Edmonton. As mentioned, this model uses the inundation data for Calgary to predict flooding in Edmonton, so inundation data for only Calgary was necessary. All data collected was in shapefile or raster format, so it could be easily manipulated in R and ArcGIS software. After obtaining data for flooding factors like land use, elevation, and hydrological features, additional features like distance to stream, flow accumulation, and slope were generated using raster tools in ArcMap. For example, slope measurement was calculated from elevation models for each city. After all features were collected and created, the data was standardized using a fishnet. Each individual cell in the fishnet has a value corresponding to each input feature. Example features are shown at right. Next, we tested which factors could be used to accurately depict the observed inundation in Calgary. The features outlined in red were used in the final version of the model. To validate our model, we looked at the percentage of true and false negative and positive results. Our resulting model has an overall accuracy of 95%, but this is primarily because most of the city does not flood. Within the areas that do flood, the accuracy was approximately 60%. We concluded that the model is generalizable, but there are locations within the city that were not predicted accurately based on the 2013 inundation data. This is the final flood map of Calgary as predicted by our model. In our last step, we input data for Edmonton for the features that were used to build the Calgary model. Our result is a flood forecast map for Edmonton. There are several steps that we could take next. We could work to refine the model further with even more features, or we could apply the model to another similar city. Overall, this model is an important tool for decision makers that don't have recent flood data available.